Okay, I hope you can see my presentation. So my name is Krstevska, teaching assistant at the Faculty of Mechanical Engineering, and I'm going to present our work with title Solutions and Procedures for Repairing a Damaged Vertical Cylindrical Tank. On this slide is you can see the content of the presentation, what we will cover, the introduction, methods for repair, experimental work, analysis, and at the end conclusion. The presentation describes the options for repairing a damaged vertical cylindrical tank, which you can see on figure 2. And on figure 1 is given the technological scheme of the system and the depositor, the vertical cylindrical tank, which is part of the wastewater treatment plant, which is located in the metallurgical plant for production of ferrosilicon. So the wastewater treatment plant station is used to reduce and neutralize the carcinogen hexavalent chromium into trivalent chromium, and its component of the tank, the shell and the floor, are severely damaged because of the tank's long exploitation and improper maintenance. Here we can see that the tank is designed for working fluid with a low concentration of sediment with this specific weight of 1 kilogram of cubic decimeters, and the condition found is 2.7 times greater with a specific mass of sediment in the tank. Is a fluid with 2.72 kilograms of cubic decimeters. So because of this excessive amount of residual sediment inside the depositor, there is a local leakage of the content from inside the depositor to its bottom, and deformation of the cylindrical casing of the depositor or tank. On this slide, we can see the components of the tank in real state. We can see the floor of the main tank, the construction of the floor, the internal small cylinder of the tank, and the casing of the body. So the two methods that are reviewed for repair. The first method is repair welding at locations where the damage is present, and the second method is addition of lost material by applying liquid composite metal. So to determine the mechanical characteristic of the materials, we will apply the tensile test method. So on figure 3, we can see the test samples made according to a tensile test standard with two different damage length of 46 and 92 millimeters, depth 3 millimeter. According to the damages similar to this were found on the tank. Here we can see the test samples for tensile testing. First, 4 samples are made with repair welding, and 4 samples are made with liquid metal, and 2 samples, probe 5 and 6. 5 and 6 are made from the base material without damages, without defects, only to confirm the characteristics of the base material. On these pictures, we can see the preparation of the samples by repair welding, the additional material, and the 4 ready samples. On figure 5, we can see in these pictures, we can see the preparation of samples with the liquid supermetal and the final samples. On figure 6 are presented with number 5 and 6 are presented the samples without defects and without repair as standard, only to compare for comparing the results of the tensile testing. And on figure 7 we can see all 10 samples. Here on this table we can see the dimensional characteristics of all of the repaired test sample for tensile testing. On these pictures, we can see the tensile testing machine that we used for the experiment, and on this table are given the dimensional characteristics after tensile testing. So the test pieces with number 1, 3, and 5 were tested until fracture, and the others, the test was stopped before the fracture. On the table are shown the strength characteristics of the tested samples, the proof strength, the ultimate tensile strength, and fracture strength of all of the 10 samples. On figure 9, we can see a comparison between samples made with repair welding and the samples made without defects from the base material. Here we can note that the samples with larger defect length fractures in the weld zone, which is opposite from the samples 3 and 4, then where the samples with smaller defect dimensions fractures in the base material. On figure 10, we can see a comparison between samples made with addition of liquid metal and the samples made of base material without defects. What can we note for these samples? The binding force of the liquid metal with the base material separated in the elastic state of deformation from the base material. The measured length of the liquid metal after the test for samples 7 and 8 are 46.66 millimeters. The plastic deformation of the liquid metal at the time of fracture from the base metal is 1.43%, and similar results are received also for samples 9 and 10. The one significant difference is in the plastic deformation of on the liquid metal, which is 0.9%. So on figure 11, we can is given a view of all 10 test samples. The samples with repair welding show greater deformation characteristics than those repaired with liquid metal for both defects. So what also we can say to conclude with this work that is not stated, so the longer length of repair welding and repair with liquid metal gives worse deformation characteristic during tensile testing. And during the experiment, also as a future work, we can monitor the deformation and behavior of the liquid metal with special measuring tapes placed on its surface. In the test with liquid metal repair, the test should be followed until the moment of separation of the liquid metal from the base material. Liquid metal repair will be used for stresses in the elastic region, and repair welding will be used in the elastoplastic region. So from this experiment, its results together with open possibilities for future research, open the further knowledge in the direction of finding the most appropriate way to repair the damage that occurs in the vertical tank as a result of its long-term exploitation. So, thank you.